Okay, this is our second last unit before we're done for grade 9, which is kind of crazy. Well, we have a little unit at the end, but it doesn't count. So we have 2.5 units left. Let's put it that way. So that's pretty exciting. So today we're going to look at simple one-step equations. We're getting into algebra, solving equations. Eventually we're going to get a lot more complicated than this. So we're just going to look at solving one-step equations, and we're going to start including integers and rational numbers, so all rational numbers, so including fractions, decimals, and integers, rather than just integers like we did in grade 8, and then in grade 7 we only worked with positive numbers. So getting a little bit more tricky, but still basically the same idea. Okay, so I just want to show you this just kind of as a review. So ways that we solve one-step equations is we can use inspection, so just kind of looking like a guess and check, or we can use the inverse or the opposite operation. So these aren't in your notes. I'm just showing you these kind of as a quick review of a one-step. So if we had m plus 3 equals 10, the opposite of plus 3 is minus 3, because we're trying to isolate our variable. We do the opposite operation, minus 3. M plus 3 and minus 3, those cancel out. 10 minus 3 gives us 7, so m has a value of 7. Or I could use my mental math and think, okay, what plus 3 equals 10? 7 plus 3 equals 10. Do another one. This one's a little bit of a tricky example because it's minusing y. So I'm just going to, we've got plus 15 minus y equals 8. So I'm going to get rid of the plus 15 by minus 15. Minus 15, negative y equals 8, take away 15. That is a negative 7. I'm just going to divide both sides by negative 1, because I don't want to know what negative y equals. I want to know what just y equals. So y equals positive 7. Looking at the next example, r is being divided by 2. So the opposite of that is timesing by 2. Whatever we do on one side, we do the same to the other. 2 divided by 2 will cancel out, so we're left with just r. So r has a value of 14. Okay, so just kind of as some reminders, the last one, if you see two numbers side by side, or a number and a variable, so a coefficient next to a variable, this is like 3 times x. So in order to isolate the x, we do the opposite. So instead of timesing by 3, we're going to divide by 3 on both sides. You can either show it as a fraction, or you can go divide by 3. Either way, doesn't matter. 3 divided by 3 gives us 1, so 1x equals negative divided by positive is negative, so negative 4. Okay, so that's just kind of a review of one-step equations. So then if we go back to here, okay, so we're going to do one-step equations, but now if you notice, these examples all have fractions in them. So let's do some review of fractions. So remember, if you have a fraction times a whole number, we want to think of that whole number as a fraction over 1. So that way we're multiplying numerators with numerators, denominators with denominators. So we're going 2 times 4 over 3 times 1, which gives us 8 over 3. Or if we put it into lowest terms, a mixed number, 2 and 2/3. Okay, we're looking at the next one. 3 times x equals 12, so we're going to do the opposite. Instead of timesing by 3, we're going to divide by 3. This is just like the example on the last page. Okay, so 1x equals to 4. 3 divided by 3 don't cancel out to 0. They cancel out to 1, but 1x is the same as just x. Reminder, if we need to divide two fractions, we kiss and flip. So what that means is the first fraction stays as 7/8. Divide becomes a kissy face, or times. 2/3 flips. We take the reciprocal. And now it's just like a regular fraction multiplication. Numerators with numerators, denominators with denominators. And if we put it into lowest terms, 1 and 5/16. Okay, the last one. Again, negative 4 times x equals 20. So we need to cancel out the full -4, and so to turn it into 1, we need to divide it by itself. So -4 divided by -4, and 20 divided by -4. So that divides to 1x, that divides to -5. Please keep in mind your sign rules. So in this unit, we're kind of pulling together everything we have worked on so far. Integers, exponents, sign rules, rational numbers, everything. Okay, so we're going to solve these ones. I'm going to show you a couple different strategies. Hopefully you can find a strategy that works well for you. So in the first one, we have 2x, or 2 times x equals 3/4. So we don't want to know what 2x is equal to. We want to know what 1x equals to. And so the way that we can do that is by getting rid of the coefficient. And so if it's being times by 2, we need to do the opposite. We are going to divide by 2. So if you remember what we did just above, in order to divide a fraction, it's the same as multiplying by the reciprocal. So 2 divided by 2 leaves us with 1x. On the other side, we have 3/4. 3/4 times 1/2. So x equals 3/8. Okay. The next part says to verify your work. So the way that we verify our work is we go back to our original equation, and we are going to substitute the answer. So instead of x, every time I see x, I'm going to replace it with 3/8. So then this is like 2/1 times 3/8. Okay. Oh, 3/8, 3/4. I'm like, I know this looks wrong. Why does it look wrong? No, 3/8. Okay, and so then we're going to solve each side, and we should get the same answer on each side. So 2 times 3 is 6. 8 times 1 is 8. So 6/8 equals 3/4. Well, those don't look the same, though. So we need to prove that they're equivalent by either reducing both sides or increasing both sides. So I could either divide this side by 2. I can notice that they're both even numbers, and then get 3/4 equals 3/4. Or I could have doubled the right-hand side and made 6/8 equals 6/8. Doesn't matter which way you do it. Okay, moving on to our next example. M divided by 3 equals -2/5. If you want to put the negative sign on one part of the fraction, I generally put it in the numerator, but it only applies to the numerator or denominator. If it applied to both, you would see a -2 and -5 like that, and then it would actually make a positive fraction. Negative divided by negative gives us positive. Okay, so it's being divided by 3, the variable. We need to get the variable by itself, so we're going to do the opposite of divide by 3, which is times by 3. So 3/1 times by 3/1. 3 divided by 3 cancels out to 1m. And we get -2 times 3, so -6/5. Or -1 1/5. Okay. If they're giving you a question in fraction form, it's probably best to keep it that way. I would only put it into decimal form if they give you whole value numbers, okay? Or rational decimals. We don't want rational decimals that are non-stopping, non-repeating decimals, okay? This one would give us a rational decimal, so we could put it into a decimal if we wanted to. And then we would verify by substituting. I'm not going to do that on this example. We'll do the next one. So this example, I know that when I have halves, those are really easy decimals to make, so I'm going to turn them into decimals. So -2.5 times k is equal to -3.5. So sometimes if you can put them into decimals, it might make your life a little easier. So now we notice that we have a coefficient in front of our variable, so it's being multiplied. In order to isolate, we do the opposite. So -2.5 divided by -2.5 gives us 1k, and -3.5 divided by -2.5 is going to give us a positive. Negative divided by negative is positive, 1.4. So then if I wanted my answer back in a fraction form, well, I could think of this as 1 whole and 4/10. And then 4/10 can reduce down to 1 and 2/5, or 2/5. If any of these fraction operations are not making sense to you, that's something you need to come to tutorial and discuss with me. Okay, I know we're taking a while on this video. It is going to be a longer one, but you'll have lots of time to work on it. So I'm going to ask you to do these 3 on your own. You might turn them to decimals if that's possible. If you get a repeating decimal or a non-terminating decimal, that's not a good idea. You need a decimal that stops in order to do the decimal method. And I want you to pick one of them to verify. You don't have to verify all 3, but pick one. Okay? Now these ones are nice. They are already in decimal form, so they should be nice and easy. So I'm going to do these ones pretty quick for you, and then the next 3 you'll have on your own. So this is a negative 1.2 times x. In order to isolate the variable, do the opposite operation, divide. So x is equal to positive 3.3. Okay, again, we could verify our answer by substituting. So negative 1.2 times 3.3 should give us negative 3.96. Negative times positive is negative, and when I calculate it, we get the same on both sides. So we're good. B, R is being divided by 0.28, so we're going to times it by 0.28 to cancel it out. Okay, so then we get R by itself, and R equals a negative 1.26, because negative times positive is negative. So again, you are going to do these 3 on your own, and then we will check them together. Actually, no, we're not going to do these 3 on your own. I'm going to show you how to do these, because these ones are a little bit trickier. I'm going to show you how to do the first one anyways. So in this case, we have 8 divided by x. So we need to do a little extra step, because the x is in the denominator. We need the x to be in the numerator. So in order to move the x to the numerator, I'm going to times both sides by x. X divided by x actually cancels out on the left-hand side. So now we get 8 equals 2x. Okay, so now we have 2x is equal 8. Well, we can divide both sides by 2. So x has a value of 4. Okay, so there's that little bit extra step. I'll show you one more, and I'll leave the last one for you to do on your own. That way. So again, p is being divided, so we're going to multiply both sides by p. P cancels out on the left. Negative 4.5 is equal to 9p. Divide both sides by 9 to get the p by itself. Negative 0.5. Okay? So you're going to try the last one on your own. Hopefully you can figure that one out. Okay. 2 written questions. I'm going to help you with these, and then you'll have some practice questions you need to try. So first one says, Winter Warehouse has winter jackets on sale for 25% off the regular price. So that means you have full price, and you're taking off 25% to get the sale. Okay? If a jacket is on sale for $176.25, what was the regular price, or the full price? So full price is what we don't know. We know the sale price, and we know the discount. So full price, let's say, is 100% of the cost. We're taking off 25% of the cost, and so the sale price is going to be 75% of the full cost, right? You're paying 75 because they took off 25. So we're going to find what 75% is of our regular price to figure out what our regular price is. So 75% of the full price is going to give us the sale price. Okay? So 75% of, we don't know what the full price is, so let's just say that's going to be F. And we do know what the sale price is, that's $176.25. So 75%, I'm going to represent that as a decimal. 0.75 of is telling us to multiply, so we're going to times it by F, is 176.25. So now I can figure out what F is by dividing both sides by 0.75. full price is $235. Or the regular price before the sale. Oops. Oh, I ran out of room. There, price. Okay. A roll of dimes is worth $5, so keep in mind that each dime is worth 10 cents or 0.10 of a dollar. Write and solve an equation to determine the number of dimes. So we don't know the number of dimes, so let's call that D. Okay? So the number of dimes is going to equal to $5. Each dime is worth 10 cents, or 0.10 of a dollar. So to find out how many dimes there are, divide both sides by 0.10. So we get 50 dimes. Now you could solve this without coming up with an equation, but the point is I want you to start noticing how to write an equation. Notice that we identified what variable we were using and what it stood for. We wrote the equation and then we solved it, and then we could also verify to double check. Okay, that was a long one. Hope you stayed with me. Good luck on your practice. We'll check those questions together.